Okay, chapter 5, flashcard video. Here we go. Taste buds. These are the sensory receptors for gustation, located on/in papillae. Structures located in papillae on the tongue that control the sensory receptors called taste receptors. Perception, unlike sensation, is when you process the neural So sensation is when physical stimuli hit your sensory receptors. Perception is when you process that stimuli as, I don't know, pain, taste, smell, depends on what it is. The processing, organization, and interpretation of sensory signals in the brain. These processes result in an internal neural representation of the physical stimulus. Review. Okay. Frequency. So this one is pitches. So higher frequencies are processed in our brains as being higher pitches, and lower frequencies are processed as being lower pitches. Low frequency and lower pitch sounds, high frequency, higher pitch sounds. Temporal coding. Temporal. It's here. So when your brain processes I honestly cannot remember. Okay. The perception of lower pitch sounds is a result of the rate at which hair cells are stimulated by sound waves of lower frequencies. Okay. Temporal coding. Review. Okay. Trichromatic theory. So that is the theory that we've got 3 types of cones in our eyes that process light, and that they each only are able to process a section or a range of wavelengths, but there's overlap between the two, so it's all good. Okay. There are 3 types of cone receptor cells in the retina that are responsible for color perception. Each responds to different but overlapping ranges of wavelengths. Okay, S cones. These are the wavelengths, well, these are the cones that process smaller, shorter wavelengths. We're most sensitive to short wavelengths and the perception of blue. Okay. And then M, I believe, is green, and S is red. Lens. So the lens is the round, clear disc in your eye through which light passes. The adjustable transparent structure behind the pupil. The structure focuses light on the retina, resulting in a defined visual image. I need to know this in greater detail. Monocular depth cues. So these are the things that let us process depth that are present in each eye. You don't need 2 eyes to use this particular particular depth Q thingamabob. Cues of depth perception that are available to each isle. M codes. So these process medium wavelengths, and these in particular are good for green, the color green, because that's the wavelength that they respond to. Most sensitive to medium light wavelengths, the perception of green. L cones. Hey, didn't shuffle these well enough. L cones. So L cones process longer wavelengths of light, and these guys are responsible for processing the color red in particular. Was sensitive to older light wavelengths, perception of red. Component process theory. Which sense is this? This is familiar. Just don't remember exactly what. Something to do with processing. Oh, is this the thing where you've got blank spaces of vision that gets filled in? The proposal that ganglion cells in the retina receive excitatory input from one type of cone and inhibitory input from another type of cone, creating the perception that same colors are opposites. Okay, so opponent, opposite colors. Okay, opponent process theory is the theory that some cone or ganglion cells receive excitatory input, and other ganglion cells slash cones receive inhibitory input, and that because of this we perceive certain colors as opposites. Okay. Still review. Additive color mixing. So this is one with light, actual light. They overlap, and that causes a mixture of the light waves. So if you put all the different spectrum light together, you would end up with white light, whereas with subtract, what's the next one? I'll get into that next. Combination of wavelengths to create certain colors. Subtractive color mixing. So this is when you take pigments, and when they overlap, the resulting color, when all of them overlap, the resulting color is black, because pigments absorb all but the one color that they appear to be, and light is not the same, it's a wavelength. Combination of pigments absorb all but the color they appear to be. Transduction. I've been using the word transduce in my flashcards a lot. I ought to be able to know what this is. Transduce, trans across, deuce, and take. It's noun. So this is when sensory input is taken to the brain to be processed by which sensory receptors change physical stimuli into signals that are eventually sent to the brain. Okay, alright, go me. Roots. Place coding. So I'm pretty sure this is the localization of sound. So place coding allows people to hear a sound and know where it comes from. The reception of higher pitched sounds as a result of the nope. Okay. It's a result of the location on the basilar membrane where hair cells are stimulated by sound waves of varying higher frequencies. Okay. What was the other one? This temporal cover. I'm still pretty sure this has to do with like the localization, but I could. Okay.